All right, so we have set up our capacitive touch sensors to activate the LEDs, or the little LED jelly beans. But now we're going to be working with an LED strip, and just to demo what this looks like as of now, I have, I'll turn the light off a little, there we go. So I have the code telling the LED strip to flash black and red, or essentially red and off, but then when I interact with it through the capacitive touch, it turns green. So it's sort of like flashing red and like a warning sign, and then going to green when it's happy. And I put kind of a little bit of a delay here on the green so it like stays green just a little bit after you're done touching it. But we're going to go ahead and add a second capacitive touch. So let me go ahead and turn this off. Okay, so there are a couple different things about this code than our dual touch code, or even our single touch code. First thing is I've included the fast LED library, and you do that, or you add that by going to Sketch, include library, and then if you don't have it down here, you can go ahead and search it in the managed libraries and just add it. There's a lot of good resources for this library in particular. So what I'm going to do here, and pretty standard, is I'm going to define the number of LEDs, and on that strip I cut out 1, 2, 3, 4, well 10, just making sure, 4, 5, 6, 7, 8, 9, 10, yep, 10. So I cut out 10 LEDs from that strip, and we'll go over how to shorten or lengthen LED strips and soldering in a future demo, but for right now, I have 10. I have my data line set up to digital 10 pinout on the board, and I'm also defining brightness. Now brightness can be set anywhere from 0 to 255, 255 being the brightness. I want to keep that kind of lower. Your LEDs last longer, draw less power, but you can set it to whatever you want, and especially if you're working with an interaction that involves triggering brightness or triggering fade. That's something to think about. And then again with the, like we did in our touch code, I have my constant integer touch 1, but I'm now going to install touch 2. And let's see, we can install that. Let's do data pin 6. I know that's PWM. And we'll make a new integer touch state for 2. Cool. So that's all set. Oh, and then I'm also setting my LEDs to read the CRGB color mode. We'll get into that below. So just making sure that I reference that my LEDs are all set up. We know how many there are. We know what pinout it's attached to, and we've defined a brightness. Cool. So, and then we got our touch stuff. So getting into the void setup, just like before, we have our pin mode. Oops. Touch 2. Input. Semicolon. So that should be the same from before. The only thing missing is we don't have pin mode LED as an output. And we don't need to do that because fast LED sets that up here. So the void setup is telling, or the void setup is reading from the fast LED library, telling the code to read to these LEDs. This is my model number of the LEDs, and this is the same model that you guys will have. So reading this model number from this data pin, GRB, I would just copy and paste this. And then it's setting the brightness to what we have established here. So just calling back to that number 50. So don't worry about changing that too much, but if you do want to experiment with brightness and fade, pulsing, or any sort of thing that we lower and raise brightness over time or over interaction, we can definitely talk about what to do. So that's it for the setup. Let's get into the loop, just like before. Touch state 2 equal, digital read, touch 2. I call that touch 2. Perfect. Okay. So before I edit this part of the code, I want to tell you what it's, or explain what it's doing. So I have set up a quick for loop establishing integer I being equal to the number 0. Now, if you remember, we talked about integers being, integers are variables. Constant integers never change. Constant integers, the touch, capacitive touch will always be associated with pinout 11. But integer touch state, integer I, this new integer we're talking about, these variables they can be on or off, high or low, or any number in between 0 and XXXX, whatever. So we're setting up an integer for fast LED to read. Actually, we're not even calling that out here, but we can. So this is totally not a waste of time to talk about. Because there's a couple different ways you can change the color, tell the LEDs what color to do. This will be important when we get down to here. So I'll call back to that in a second. But I am creating this if-else statement, or else-if statement. So we have right now, if touch state 1 is on high, then fill the LEDs green. And you saw that in the video. Else if they're nothing is being touched, then do the red flashing. But we want to change this to, wrong button, and touch state 2 equals high, do this. Sweet. Okay. And I think we will need else if touch state 1 equals to low, and touch state 2 equals to high. We will do fill the LEDs with a solid color. LEDs, let's do all 10. So I'm telling fill solid, fill the LEDs, all 10. So this could be, maybe I just want to do, let's leave it 10 for now, and then I'll tell you. some more. CRGB equal or colon. Let's do yellow. And you see as once I put CRGB colon, some of these colors pop up, and I will link the color reference in Canvas, but let's just call this yellow now. Let's do green yellow. Okay, and then we have to tell, so we're telling it to fill solid all 10 LEDs in a green yellow color, but we also have to tell it to show. So this fast LED show statement should always follow the command you're telling the LED. We'll put a delay in there. Let's do just 500. And then bracket closed. Cool. And we'll do one more else if statement. Touch state 1 equals let's see, we want to get a combination of all of them. High and touch state 2 equals low. Bracket. We'll do fill solid LEDs. We're just going to leave that all 10 for now. CRGB colon. Let's do, what can we do? What kind of green? Maybe like, actually, chartreuse is, let's do, I want to stick with the idea that green is, the color green indicates good, yellow is not good but not bad, and red is bad. Let's do coral. That might be okay. Fast LED dot show semicolon delay, just a quick delay semicolon. Okay, that all looks good to me. Let me just verify this. Okay, cool. So if both touch states are on, fill all the LEDs, all 10 LEDs, with a solid color green. Then a little bit of a delay. Else if touch state is 1 is low and touch state 2 is high, so only touch state 2 is being activated, LEDs will fill in a green yellow. But I think what I want to do actually is change these to, because we have 10 LEDs, I'm going to split it up so that the beginning of the LED strip will be activated here, so only if touch state 2 is on, and the other 5 LEDs will only be activated if touch state 1 is activated. I wonder if I have to add in a black for the first LEDs, but we'll see. I feel like I might, but we'll see. We'll plug it in and test. So if none of these things are happening that I stated above, that means neither touch state is being active, I want the LEDs to fill solid, all 10, in red, and then fade to black by, that's just a statement that essentially just reduces the brightness of the LEDs. So fade these LEDs, all 10, by 250 brightness levels. If I made it 255, that would mean it would be completely zero, like zero brightness. Cool. So then show, and then a delay. But before we test, I do want to talk about that I integer. We can, maybe I don't, but another way to show LEDs is by using the integer I. I being calling out to which LED we want. Okay, I totally forgot to mention that the for statement in the loop actually not only references the integer I being the LED we are addressing, but I also is saying that it will consider the number of LEDs that we call out at the beginning of the statement, and then with that I++ in that for loop, meaning it'll consider, not only consider how many LEDs there are, but activate each one in an ascending manner, if that makes sense. So let me show you what that would look like. You already saw the original, where all LEDs were, the red LED flash, the black was occurring in every LED synchronously. But let me get me plugged in here. And let's get that camera back on. Okay, so recording. This is what it looks like with that fade to black. But let's send over the new code. Oh, shoot, I have to connect. So we have a ground here. I should unplug. Voltage in. And then this is in digital 6. Pretty sure it's so tiny it's hard to see. Plug her back in. Okay, so I have the new code in here, and you see that we have this descending sort of motion, and what that is doing is, or what is making that do that action is in LEDs I+1, it's saying LED, starting at LED number 0, which is always going to be your first one, perform this action, CRGB equals black, on every LED ascending +1. So I could do the maybe ascending at 3. So it starts at 3 and continues. But I can also, before we move on, just comment these out, show you that we can fill this with black, We can fill this with blue. And it's just another way to fill, but it's more of individually addressing the LEDs rather than the fill solid. So let's turn this guy back to the way we want him. So we have flashing red, and let's press 1. Okay, so we have touch state 2 being active. That means I should have that green yellow. Let's do touch state 1. I have coral active. Oops. And let's do both at the same time. Green. With that little bit delay. Cool. So I will post this code and send over a schematic. It should all be on Canvas. And this is what we will be working on in class. All right, cool.